Hello friends, this is our domain 2 and why this domain 2 is important because domain 2 will cover your 25% of syllabus. That is the most important thing of domain 2. Okay, so having a grip on your domain 2 will be most helpful for your CSP examination. And so this notes we have developed by using complete your previous year's question paper and also your syllabus has been completely covered. Okay, please go through these notes, very, very important notes. And the system safety techniques, we will first understand what is fault tree analysis, event tree analysis, FMEA, HAZOP, MORT, CCA, bow tie. Very, very important. Definitely one question will come. So FTA means what? It is backward, deductive, top down. ETA means what? It is forward, inductive and bottom down. So ऐसा पढ़ेगा तो कुछ समझेगा नहीं. So हम एक एक करके हम देखेंगे. Okay. Just for your understanding, they will ask in the keyword pattern. Okay. Keyword they will be asking. Like FTA, you must understand what is the keyword. Backward, deductive, top down. Okay. We will understand why this is backward, deductive and top down. Event tree analysis, it is forward, inductive and bottom down. FMEA, forward, inductive, and bottom up. Then HAZOP is using guide words पूछा है. MORT, it is tree-based investigation. CCA, it is backward and forward both. Bow tie, it is barrier-based visual model. जब ये visual model कौन सा है पूछेगा तो it is bow tie. Now we will understand each and everything in detail. Okay. So see, fault tree analysis. Now this fault tree analysis, see fault tree analysis, why it is top down, backward, deductive and cost based? Because this fault tree analysis, you are, for easiest way to understand this fault tree analysis is that fault tree analysis, you are actually a detective. Okay. You are actually a detective. Why you are actually a detective means what? What is detective? Detective क्या करते हैं? Detective will be going into the site, accident site, and they will be using their lens and they will be understanding why that happened. क्यों हो गया? Why ऐसा क्यों हो गया? ऐसा accident क्यों हो गया? They will be checking. Okay, they will be trying to understand the root cause. Okay, ekdam final root cause they will be trying to understand. So when they are trying to do that, this is actually known as backward approach. You are moving backward, up पीछे जा रहा है. This is backward. Why it is known as top down? Because one big accident has happened. From the top, you are moving downward. You are coming downward. Why this has happened? Why? So this is top down, backward, deductive, and cost based. So that is your fault tree analysis. Now fault tree analysis uses Boolean logic. See, Boolean logic, this is also a question. Boolean logic means there is AND gate and OR. Okay. So this is using the Boolean logic to understand this top event. We top event ho gaya. So this top event Q ho gaya. There is a fire accident. So fire accident happened because of there was this one oil was there was petrol was there, and then oxygen was there, and then spark came through cigarettes. So all these three factors caused this big tree, that is your accident. So fire was there, and oxygen was there, and your cigarette was there. So and means what? All these factors coming together will cause that accident. Or means what? Any one of the factors is coming that will cause your accident. So this is your fault tree analysis, your logic gates, AND gate and OR gate. AND gate means all the event has to occur. OR gate means any one has to occur. So see, for example, you are actually analyzing an event. Okay. AND gate is there, OR gate is there. So fuel, oxygen and heat, fire will occur. And OR gate means what? Only one thing is required. AND means what? Okay. So this is AND gate and OR gate. That is our fault tree analysis. Now we have to understand certain basic definitions in this fault tree analysis, which is cut set, basic set, underdeveloped events in fault tree analysis. Okay. So what is this top event? In fault tree analysis, this is your tree. Okay. You are analyzing the fault tree, the big tree. The big tree, the top event is what? Your accident. Your accident is your top event. Okay, the top event is your accident. Now you are understanding why this accident has occurred. You are moving downwards. You are moving downward and understanding why this accident has occurred. So the bottom event is known as the most bottom event. The most bottom is known as bottom event. Okay, the lowest event. Highest event is the accident. That is your top event. The bottommost event is the bottommost event is known as bottom event. So bottom event would be your root cause. That is why this top event has happened. Okay. So top event is your undesired system. Okay. That is top event. And what is this cut set? Cut set, there are two types of cut set: normal cut set behave or minimal cut set behave. See, cut set means the various causes. अभी देखो इधर एक फ्यूल है, इधर ऑक्सीजन है, इधर सिगरेट है. ओके, ये तीनों भी एक साथ आएगा तो ही योर टॉप सेट विल कम, योर टॉप accident will come. That is your cut set. So this is the combination of basic events simultaneously occurring to cause the top event. ये तीनों भी एक साथ आएगा तो ही top event आएगा. That is your cut set. Now what is the minimum cut set? Minimum cut set means what? ये तीनों भी आने का जरूरत नहीं है. इसमें से अगर सिर्फ दो होने से, if any two is coming and if the accident is occurring, then that is known as the minimal cut set. मतलब minimum that is required, that is only required, that is minimal cut set. Minimal cut set means what? Minimal cut set is the smallest combination of basic event that is sufficient to cause the top event. So for getting this top event, this three things is not required. ये तीनों भी होने का जरूरत नहीं है. Okay, इसमें से कोई दो होगा तो ही आपको एक्सीडेंट होगा. That is minimal cut set. See, for example, valve A, pump B and sensor C fail होगा तो ही एक्सीडेंट होगा. लेकिन sometimes valve A and pump B अगर fail होगा तो एक्सीडेंट होगा. So that is the minimal cut set. Minimum अगर उतना ही चाहिए then accident will occur. Okay, so that is your minimal cut set. So minimal cut set is sufficient to cause the top event. Sufficient. 3-4 जरूरत नहीं, only 2 is enough. Contains no unnecessary event. There is no unnecessary event. So that is the basic event to cause the accident. Okay, shortest irreducible paths to the system failure. So minimal cut set is this is important, shortest irreducible paths to the system failure. This is shortest path to the failure. तीनों जरूरत नहीं, only 2 is enough to cause that event 3. Okay, then order of minimal cut set. See, order of minimal cut set means what? First order failure is there. Second order minimal cut set is there. First order means what? Only one basic event is required. Second order means what? 2, एक पंप भी चाहिए और दूसरा कुछ और भी कुछ चाहिए. Then only that failure will come. तीसरा, that is third order minimal cut set means what? 3 basic events होना चाहिए. 3 events, एक पंप, एक दिस वन, एक ब्रेक फेल होना चाहिए और दूसरा एक और कुछ फेल होना चाहिए. मतलब सी मिनिमल कट सेट, उसमें फर्स्ट ऑर्डर है, सेकंड ऑर्डर है, थर्ड ऑर्डर है. फर्स्ट ऑर्डर मींस व्हाट? वन थिंग इज रिक्वायर्ड टू फेल. सेकंड ऑर्डर मींस व्हाट? 2 चीज होना चाहिए फेल होने के लिए. थर्ड ऑर्डर मींस व्हाट? 3 चीज होना चाहिए फेल होने के लिए. वेरी वेरी सिंपल. ओके, बट व्हाट एज अ सेफ्टी प्रोफेशनल यू नीड टू अंडरस्टैंड व्हाट इसमें से फर्स्ट ऑर्डर है, सेकंड ऑर्डर है, तीसरा ऑर्डर है. इसमें से विच इज मोस्ट डेंजरस एज अ सेफ्टी प्रोफेशनल? See, this only one thing has to fail to become a big accident. Here, 2 things has to fail to become a big accident. Here, 3 things has to fail to become a big accident. So, always for a safety professional, you need to be more careful about this first order minimal set failure, because this is only one basic set होना चाहिए for become a big accident. Okay, because here that is more dangerous. Only one set is required. Okay. In general, a lower order minimal cut set indicates greater system vulnerability. That means easier to fail. That is the most important. Okay, lower order minimal cut set. That is why second order failure से भी ज़्यादा important है first order failure, that you must understand. Indicates a greater system vulnerability because fewer failures are required to produce a top event. When only fewer failures are required, 3 ज़रूरत नहीं, only 2 failures are required to become a great event or big event or top event or an accident. Okay, first order set requires only 1 failure, second order set requires 2 failure, and third order set requires 3 failure. Okay, got it. Now, event tree analysis. We understood what is fault tree analysis. Fault tree analysis, that is top-down approach, that is deductive approach. And there is a big fault, and then we are moving downwards. That is fault tree analysis. And in the tree analysis, there is Boolean logic, which is and OR gates are there, and then you have your this one cut set, basic cut set, top set, and bottom events. Okay, now we are moving on to the event tree analysis. Fault tree analysis, what we told, we are actually a detective. We are detecting. That is why we are moving backwards. It is a backward, top down, backward approach. Now it is event tree analysis. In this event tree analysis, we are moving forward. It is inductive approach. Here we are actually checking what will happen next. What will happen next? That is the event tree analysis. One event has happened and we will be checking what will happen next. We are moving forward. You start with a single spark, that is initiating event. There is an event and you are moving forward. You are looking forward. See, for example, one valve has broken. Now you are moving forward. If that valve has broken, what all safety control system will act? That is event tree analysis. You are analyzing the event. एक event हो गया, अभी आगे क्या क्या होगा. Looking forward into the future to see what happens as your safety system try to stop it. See, this is forward. You are moving forward. It is bottom up. There is an event in the bottom, and you are moving forward in the top. And inductive. Inductive means what? You are actually checking what will happen next. You are checking what will happen next. Inductive. You are analyzing. Okay. Now we will understand an example. See, for example, there is a facility. Okay, there is an facility. A facility experiences sudden loss of primary power. Now, primary power has lost. That is an event. An analyst wants to map out how the backup generators UPS system manual intervention steps will perform chronologically to determine if the final system state. Now, the event is that your electricity, your power has lost. Now you want to understand what all things will come in the next, whether the DG will be working, whether the UPS system will be working. So you are moving forward here. Okay, you are not moving backward, you are moving forward. You are checking what all things will happen. You are doing this inductive approach, not deductive approach. Okay, you are moving from bottom to top. That is event tree analysis. Now, if an aircraft, there is a sudden catastrophic release inside the aircraft, some vapors has been released. Okay. Now, as a safety professional, want to utilize top down. In the question itself, it is given top down. Top down means what? It is fault tree analysis. Okay. Deductive cause based technique to visually map out the subsequent combination of equipment failures. Here you are moving backward. And human errors that could trigger this event. Why this event has occurred? That is the question, that if you are finding that, why this event has occurred, you are moving backward, you are moving into the past, you are working as a detective, then it is fault tree analysis. But you are moving forward, what all things will happen? What all things will happen in the future? That is event tree analysis. Okay, this is fault tree analysis. You are moving backward, it is past. A pressurized chemical pipe or a paint line ruptures, releasing a toxic stream. The facilities safety manager want a forward-looking bottom-up. Here itself the keyword has given. So keyword is very important. It is forward-looking, bottom-up, consequences-based tool to evaluate whether the downstream safety functions will succeed or fail. Whether it will succeed or fail, you are moving into the future. You are doing inductive approach. You are actually bottom-up approach. So it is event tree analysis. Very easy. Okay. So this is the keyword. You can easily understand what caused this top event, why this event has occurred, what caused, that is fault tree analysis. What happens after this initiating event, it is event tree analysis. Do safety systems succeed or fail? Whether it will succeed or fail, it is event tree analysis. Which combinations cause the top event, it is fault tree analysis. Okay. Now, failure mode effect analysis, that is our FMEA technique. Now, in this FMEA technique, failure mode effect analysis, in this name itself is there. Most of the time, you try to have some kind of keywords with you. Okay. Like, then it will be easy for you to remember also. Now, failure mode effect analysis. There is a failure. You are understanding the mode and effect analysis. Here, you are actually inspecting each and every part of the machine. Mechanic inspecting, just think FMEA as like a mechanic inspecting a machine part piece by piece before it leaves the garage. So failure mode effect analysis means what? You will be checking each and every part of the machine, okay, whether it is working properly or not before it is being rolled out. So instead of looking, instead of just looking after the explosion or something like that, you will be checking the machine part by part. What you will be checking, like if this part breaks, what would be happening? That is, so you are moving into the future. If these parts break, what would be happening? So this is definitely inductive or deductive. It is inductive. What happens to the whole system if it does? So that is, you are moving into the future. So that is why it is inductive approach. Okay. And it is forward. It is forward means what? We are moving into the future. We are checking if this part breaks, what will happen? So we are moving into the future. Bottom up. We are checking each and every component. That is why it is moving from down to up. You start by the smallest level and then you trace into the when you move into the future. Okay, it is step-by-step approach and component. Every step you are checking. That is failure mode. Now, this is a failure mode effect analysis, and in the exam, they might ask you failure mode effect analysis is also there, and failure mode effect criticality analysis. You are looking at the critical steps. What are things will happen if one component fails? Okay. So there are FMEA failure here, FMEA failure mode effect analysis. Okay. failure mode effect analysis. See, failure also, what item has not performed, mode, where it has failed, अगर leaking हो रहा है क्या, stuck हुआ है क्या, closed हुआ है क्या, effect, what is the effect, और उसका आप analyze कर रहा है. Okay. Then this FMEA is often first qualitative. Quantitative or semi-quantitative data can later support critical rank. Okay, it is actually qualitative FMEA, and then qualitative and also semi-quantitative also can help support the critical analysis. FMEA, FMECA adds critical analysis. Always FMEA we are using, FMECA also can be done. Okay. Then risk priority number in FMEA, what it comes is risk priority number. Now, what is this risk priority number? Risk priority number is actually a number which helps you to understand whether the risk is easier to detect or it is actually impossible to detect. So the mantra here is that if you are having high detection score, like see risk priority number, you will be getting by multiplying severity, occurrence, and your detection. Okay, you have to multiply the severity, then you have to multiply the occurrence, and then you have to multiply the detection. So if you are multiplying all these three values, you will be getting your risk priority number. Okay. So severity or likelihood, and you know what is risk? Risk is what? Severity into likelihood. Into detection, you are multiplying, you will be getting risk priority number. So you have your high risk priority number like 9 or 10 means what? It is very difficult. It is nearly impossible to detect it. That is high risk priority number. Low risk priority number means what? It is very easy to spot the risk very easily. Okay, that is the importance of this risk priority number. Okay. Now, FMEA and for a failure mode effect analysis and event tree analysis, both are actually inductive. Okay. Fault tree analysis is what? It is detective. Why it is detective? Because we are moving backward from when big event has occurred, where a big fault has occurred. See, you understand the basic meaning. Big fault has occurred. Now you are analyzing that. You are a detective. That is fault tree analysis. You are moving backward. That is detective approach from top down approach. Okay. If you are learning like this, then no one can stop you for getting this CSP. Okay. Now, what is the difference between FMEA and ETA? FMEA is actually failure mode effect analysis, and ETA is what? Event tree analysis. And both are actually inductive approach, but FMEA, the methodology, FMEA is a spreadsheet metrics. Okay. So FMEA means what? We will be understanding each and every component. We will be checking how it is failing and how it will be affecting our overall component. That is, we will be having a spreadsheet. We will be having an Excel sheet for that. Okay. ETA means what? Event tree analysis. It is a chronological tree. One is happening, next is happening, next is happening. We are moving forward. We are tracking the path. What will happen? Okay. It is like a tree, like just like a fault tree analysis. It is also a tree approach. Now, hazard operability study, that is HAZOP. HAZOP we will be using for mainly for which plant? We will be using for our process plant or our oil and gas plant or our refinery. We will be using HAZOP, hazard operability study. It's a structured brainstorming session. It is a brainstorming session means what? You'll be doing a brainstorming session. Okay, you'll be taking ideas from all the people who are participating in this HAZOP analysis. You'll be checking, you'll be asking them what will happen, what will happen, what will happen. That is, you're doing brainstorming, okay, or chemical or process plants instead of just guessing. This is actually multidisciplinary team. You will be having multidiscipline. So many, not only chemical people, you will be asking the safety people to join. You will be asking the engineers, operators, workers. Everyone will come together and then they will be telling, sir, this will happen if this will fail. So this will happen if this will fail. So everyone will be contributing their own knowledge for that. That is HAZOP. Okay. The objective of this HAZOP is to identify deviation from design intent along with the cause and consequences. So if the pump is there, the pump will be working in that design condition. Okay. So everyone will be telling, so if the pump will be working in this 40-degree, it is normal operation. But what will happen if that 40-degree is converted into 75-degree? What kind of failures can happen? Where it will fail? If failure also happens, what will happen? So to identify the deviations from design intent along with the cause and consequences, that is HAZOP. HAZOP formula is guide word. You will be having a guide word and parameters. Okay, HAZOP, it is actually, HAZOP will be having guide words and parameters. See, guide words and parameters, we will be understanding to check the deviation. We will be checking the deviation, how far it has deviated. That is HAZOP analysis. How far it has deviated from the normal operation. So for that, we will be having a guide word and parameters. Guide word and parameters, if they are saying, then that is HAZOP approach. Okay. So guide word is what? No, more, less, reverse, other than. Parameter is what? Parameter means what? If a pump is working, pump का क्या parameter है? Flow है, pressure है, temperature है, and flow material है. So for example, no flow means what? Pump के अंदर there is no flow. Okay, so what all problems can come? If there is more pressure inside the pump, what all parameters can come? If the temperature is less, then what all parameters can come? If there is reverse flow, other materials are used, what all parameters can come? So this is our HAZOP analysis. Okay. HAZOP analysis, what you must understand, there will be a guide word and parameter. So this we will be changing to get the deviation. What we are checking in HAZOP, we are checking the deviations from design intent along with the cause and consequences. How far it has deviated. That is what we are checking. Okay. Now in this HAZOP, most important thing that you must understand is that HAZOP ke paas node and report. Okay. What is this node? See, if you are talking about one pump and all, it is very simple thing. But here we are not talking about one pump. Here we are talking about big refinery. So in that there will be so many equipments, there will be so many pipes and all those things. So that is node. Because the chemical refinery is too massive to study at all once. So we will be actually having in our A4 paper, we will be having a small section of that. And that small section is known as node. A node could be a single storage tank, a specific distillation column, or a section of pipe. The analysis is strictly done node by node. So in the question, if they are asking node, it is our HAZOP node is what? A small section. Okay. So then you will be having a HAZOP report. Once everything is finalized, you will be having a HAZOP report. Okay. Now what is PHA? PHA is preliminary hazard analysis. Okay. PH is an early stage. It is very important. It is an early stage hazard identification method. Okay, PHA is early stage. The first stage of hazard identification is PHA. Okay, also known as gross hazard analysis. Now, what is this cause consequences analysis? Cause consequences analysis means what? It is actually your combination of event tree analysis and your combination of fault tree analysis. Okay, fault tree analysis or event tree analysis का combination है what? Cause consequences analysis. It combines the backward fault tree analysis and to pinpoint the root cause with a forward event tree analysis. Okay, fault tree analysis, you know, it is backward, and event tree analysis, you know, it is forward. So the combination of fault tree analysis and event tree analysis is what? Cause consequences analysis. Okay. तो वो दोनों का कॉम्बिनेशन. तो फॉल्ट ट्री एनालिसिस में आपको क्या मिलेंगे? लेफ्ट साइड में फॉल्ट ट्री एनालिसिस आएगा, राइट साइड में आपका इवेंट ट्री एनालिसिस आएगा. सो व्हेन दिस टू आर बीइंग कंबाइंड, इट इज cause consequences analysis. Here you will be getting the root cause. Fault tree analysis will be checking the root cause. क्यों ऐसा हो गया? You are checking why this has happened. A big accident has happened. You are acting as a detective. You are moving backward. You are having a detective approach. Detective approach. Also, you are having a deductive approach. That is fault tree analysis. Now, if you are moving forward, inductive approach, that is your event tree analysis. That is in your right side. So here you are getting the cause of the event, root cause. Consequences you are getting in the right side. That is your event tree analysis. Consequences. Once the pump has failed, what all things can happen in the future? That is consequences. Okay. Next one is your bow tie analysis. See, you repeatedly hear this again and again and again so that it will be registered in your mind. And also please read these notes. That is very important. Okay. Now this bow tie analysis, it is actually, see, if you are asking, someone is asking system safety approach in this, what is the visual analysis? If some question is coming with the visual part, means what? It is bow tie. See, bow tie means what? The English people will be wearing the small tie. Okay. Not the long tie, but the small tie. This is your bow tie. Okay, this is your bow tie. In the bow tie, this is your bow tie analysis. There is left side and right side. Just like our cause consequences analysis, here also you have the left side and right side. So what is this left side? Left side, you have your prevention barrier, and then you have your middle, this one. Then you have your middle top event, and then bottom you have your mitigation barrier. So see, this is your bow tie. Okay, in bow tie, the center one is what? Center one is your event. Okay, event. That event has, that is your center now. Left side is what? It is your prevention, how you can prevent. Okay, and right side is what? Right side is your mitigation barrier. That means what all things you can do to mitigate. Okay, so if some kind of accident has happened, see, for example, the fire has happened, mitigation means what? You are reducing that fire's impact. That is your mitigation barrier. Now, what is prevention? Prevention means what? How you can do, what all things you can do to prevent that fire. Okay, so means what all things you can do to prevent the fire. That is your having regular audit and all those things is your that is your left hand side. Right hand side means what? If that event has occurred, this is an event. So event, this is an event which is your middle one. Center one. Left side is what? It is a prevention barrier. In order to prevent this event, what all things you can do? Audit, inspections, etc. Mitigation means what? Mitigation is in the right side. Mitigation, what all things the event has occurred. Now, what all things you can do in order to reduce the severity of that. That is what is your mitigation event. Okay. That is left side is your reduce the likelihood, how you can reduce the event. Right side is what? Reduce the severity. If that event has occurred, what all things you can do in order to prevent, in order to reduce the severity of that event. Okay. So next one is your MORT. MORT is what? Management Oversight and Risk Tree. That is your MORT. So MORT, here they are actually looking into the management failure. What all things the management has not done. And that is why the accident has occurred. It looks onto the entire management system. Okay. MORT is actually accident investigation tool, but here we are checking the management's failure. MORT is useful when the incident suggests a failure in policy, supervision. So if someone in the examination is telling because of the failure of management, because of the policy, supervision, training, etc., it is MORT. Okay. See, sometimes what happens is that management knows that the equipment is not functioning. Management knows that there is no guard in that equipment. There is no prevention mechanism, or sometimes the equipment is malfunctioning. Still, the management is saying, please carry on the work. So then that is MORT, Management Oversight Risk Tree. Management is responsible for that accident. Management knew about the specific hazard, but explicitly decided to accept the risk without adding more controls. Management is knowing that, still it is moving forward. So that is MORT. Okay. Say, for example, there are specific controls are missing, or management is not having proper system, or management knows that, see, there is a problem, but we can do that. Is knowing that also. It is an assumed risk. Okay. Now JSA or JHA also we tell, job hazard analysis or job safety analysis. Here we are actually dividing the whole job into various steps, and then we are analyzing each and every step. So if they are asking, JSA is a task level tool. Okay, every job, each job we are analyzing into various steps, and then each step we are analyzing. So that is why it is known as task level tool. That means it is a specific job we are taking and then we are analyzing. So it is task level 2. Okay. It is practical behavior. Okay. It is also behavioral. That is also very important. So JSA, what is the procedure? We are selecting the job. Okay. We are selecting the job, then breaking the job into steps and identify the hazards. Okay. Identify the hazards at each steps and determine the controls. So who creates the JSA? That is an exam question. The work group, who is performing the task, that who they will create the JSA. Okay. Worker involvement is a strength here. JSA, it is a step-by-step task-oriented process. That is JSA. Okay. JSA is behavioral. JSA is behavioral. That is also very important. Okay. JSA analyzes the human being performing the task. That is why it is known as JSA is behavior. Okay. FMEA is not, it is machine component we are checking. Fault tree analysis actually analyzes the machine and FMEA analyzes the component. But JSA is what? It is behavioral. How the person is behaving, that we are checking in this by effectively dividing the whole job into various tasks. That is important. Please keep in your mind. Okay. Then THERP. THERP means what? Technique for human error rate prediction. That is your THERP. It is primarily devoted to human error analysis. So human error, if you want to check the individual human error, MORT is what? MORT is a management failure. THERP is what? THERP is what? How the human error has failed, how the humans has failed. Then it is your THERP. Okay. So for example, human error probabilities. How much probability is there for a person to fail in that? Okay. Or performance shaping factors. Why this performance of that particular individual was bad. That level they will be telling about this THERP. Okay. Now reliability, definitely one question will come. So there are two types of reliability. One is system, one is parallel system is there, and another one is series system is there. See, reliability, we will take this as this involves mathematics. Mathematics will be having a separate session for that, because if we are taking mathematics in between, the problem is that you will be losing the focus, and it will be difficult for you as well. So what we'll be doing is that we will be covering this mathematic portion all together. Okay. But just for your understanding, I will be telling you that this reliability. See, what is this reliability? First of all, reliability means what? Reliability in safety means if you are purchasing some kind of mixie, for example, you are purchasing a mixie. So how much it is reliable? How much it is reliable means what? How much the mixie will work for the next 2 years. You will be saying that Toyota is the most reliable car. But you will be saying another manufacturer is that manufacturer is not so reliable. Reliable means what? Without any kind of error, without any kind of defect, it will be working in its lifetime. So there are two types of reliability. One is series reliability, another one is parallel reliability. Okay. So reliability in series reliability means what? Every component has to work. Okay. So series reliability requires every component to work. Parallel reliability means what? See, there are four components. See, for example, five components is there. In series reliability, all these five components should work. Okay, if any one component is failure, then the whole system will stop working. In parallel reliability, for example, there are five components. Even if one component fail, there is no problem. All the component will work. Okay. See, for example, in our house, there will be this one, there will be current, the connection will be there, current will be coming from the main fuse, and then your TV is working, your laptop is working, everything is working. Now what if your MCB is getting failed, or your ELCB is failing, or your there is a problem with your distribution, then whole system will fail. But in case of an operation theater, what will happen? There will be a connection, the same connection from your home, which is also going into operation. There will be a hospital. It will be going into the operation theater. The operation theater, every time it has to function. So they are giving parallel system. Parallel system means what? Even if one system will fail, the whole system will not fail. See, for example, in operation theater, the line is coming from that line. You have your DGs there, inverter will be there, UPS will be there, so many systems will be there. Even if the connection is failing, you have your battery backup is there. Even that is failing, then also your UPS is there. Even if your UPS is failing, then another backup will be there. So that is parallel system. Even when one system is failing, the whole system will not fail. Okay, that is parallel system. So always in your safety concern, like operation theater, etc., you will be having your parallel systems for redundancy. Okay. So series system means what? In series system, every single component must work perfectly for the system to survive. If one part fails, the entire system goes down. That is series system. Okay. Now, what is parallel system? The max part, you don't worry. Max part we will cover after the end of the class, whole module, max class. Okay. All the 7 modules, max class, we will be covering together. Now, parallel system is what? That is redundancy rule. In parallel system, you have a backup. You have backup every time. Just imagine the operation theater. System only fails if every single parallel path fails. All the 5 components अगर fail हो गया, सारा कंपोनेंट्स फेल हो गया, तभी ही ये सिस्टम फेल होगा. एक कंपोनेंट फेल हो गया, नो प्रॉब्लम. 2 कंपोनेंट फेल हो गया, नो प्रॉब्लम. 3 कंपोनेंट फेल हो गया, नो प्रॉब्लम. 4th कंपोनेंट फेल हो गया, नो प्रॉब्लम. 5th कंपोनेंट फेल हो गया, नो प्रॉब्लम. And 6th component fail हो गया, then the whole system will fail. So that is why parallel component is we are using for the emergency and all. Okay. Now moving into further, which is our leading and lagging safety performance indices. Okay. We will have in our next session, because if everything is being given in one module, then it will be difficult for you to understand as well. I will be giving in your second video. Okay.